Hi, welcome back to Element 14 Presents. My name is Mark. Today's video is all about a pumpkin for Halloween. And instead of hollowing out a pumpkin, I did something special. I 3D printed it so I can use it over and over again every year. And it has a Larsen scanner, so it looks like a Cylon. I did a video on the Larsen scanner a while back, and now I have a perfect purpose to use it, combined with another project I did, the Vocoder. And I'll show you more about that in a minute. And you know what? A pumpkin is not a pumpkin without some decent electronics. Actually, this project was built in anticipation of the annual Element 14 Community Halloween Hackathon, and you can participate. The hackathon is back for another year, and there are many prizes to win. All you have to do is submit a write-up, maybe some images and a video, pitch your idea about an electronic project with theme Halloween. Projects could be anything from costumes, decoration, props, something to scare your neighbor. It's up to you. The deadline for submission is the 9th of November, so you still have some time. Check out the link below and get involved if you dare. Now, back to the project. Like I said, the pumpkin has something special. Not only does it have the moving eye, but I also included the vocoder. And by now, I made a redesign of my vocoder that I did previously, and I combined it with the Larsen scanner. Basically, it's one device that can be used in cosplay or Halloween. And indeed, it does have the vocoder, so let me show you. Talking. Welcome to Element 14. Now let me show you how I did it. Okay, so the schematic itself is not that complicated. It looks complicated, but it's basically the same electronics as I did on my previous vocoder. The difference is I designed the PCB and I implemented the Teensy audio board on board. And basically what you see is we have a power supply to generate a 5-volt power. And of course it has its own fuse and a little 2 diodes for short protection. And basically what happens is if you plug it in backwards, D2 will start conducting and it will blow the fuse. Simple as that. It's a quick and dirty solution that works each and every time. We have our Teensy board, which is the microcontroller, and then we have our audio codec. And basically that's the audio chip, and it's literal but almost a copy of the data sheet of the audio chip. And basically this is exactly what the audio board, the Teensy audio board, is all about. I just implemented it on board. It has a line in, a line out, a mic in, and a headset connection. Then of course I added a display because I want to see my settings. And then we have our general I/O. We have our potentiometers, we have a switch and another switch, actually 2 push buttons. One is used to change the function of the onboard function generator from the vocoder, and the other one is not in use yet. We have the pixel LEDs. Okay, so the pixel LEDs are 2 ways. One is not in use, is pair, and the one I'm really using is connected through a jack, and you can just easily plug it in and take it out whenever you need it. That's easy for cosplay. And that's all there is to it. So although the schematic looks complicated, it's really not. And then again, take a look and you be the judge. Okay, so the new design of the vocoder combined with the Larsen scanner doesn't take a lot of components to be added for it to be complete. You'll have to add the Molex connectors or pin headers if you prefer. We have a few potentiometers, a Teensy, and of course a display. And then I'm using a pin socket to mount the Teensy and the LCD, basically because the Teensy is quite expensive and I want to be able to take it off if needed. So let's put all of this in here. First I will add some headers to the Teensy. Okay, so you can just cut part of the Teensy header that you need, and I already did that. So I have 2 pieces that fits the Teensy, and I'll mount them right there. And then the Teensy will be inserted here. I'll do the same for the display. I have a little header of 4 pins that I will put on the display, and it will go there. And of course I will put some bolts in the display, bolts and nuts, to keep the display in place. I have some small ones like this that will go right there, and then I will put a nut on the other side like so. I will mount that in a minute when I start soldering. Then of course this one we don't need anymore. We have the potentiometers, they go there. We have our Molex connectors, or another preferred connector with the same pitch that you can use. So that's where it goes. I will flip it over and start soldering. Okay, so the soldering is almost done. A few components left. We have our one connector left. And that's it. Now with everything in place, we flip it over. That would be like so. We have our Teensy, we have the display, our potentiometers, don't forget the fuse, and that's it. And then basically we are ready to hook it up. Okay, so I designed a nice case for this, and the PCB will fit right there. I already mounted a sliding switch for the power, and this has room for a 9-volt battery, goes right there. And of course there's a battery clip that we have, but first let me solder the wires of the battery. Plus 9 volt. It goes right there. And then we need a little wire to go from the switch. Like so. And then this goes to the plus and minus connector. Plus and minus of the power connector, which would be right about there. And basically that's all the wiring. So the wiring we put nicely like so. And now if I put in the battery, you should be able to switch it on and off, because this one has already been programmed. Okay, so to design the pumpkin I use Onshape. You can go to the website onshape.com and you can create a free account, because for individual use this is free to use. So after signing in, you have several projects. I'm working on my pumpkin, and basically to draw a pumpkin there's a few things you need to do. The first thing I did was created an arc from an origin point with some construction lines, and the arc kind of has the outline of the pumpkin. Next I did here a circular pattern. Actually it's a ellipse, and I did another one, and that's right there and there and there, and I think one more there. So, and what you see now is a segment from the pumpkin, and I needed to connect these circles, and there's a function called loft. And what I did, let me show you the loft. Basically this is how it's connected, and you have one segment of the pumpkin, and then all I needed to do was to revolve this around this construction line in a circular pattern. And there you have the base of your pumpkin. And then to show you what that looks like completely filled is like this. So that's the pumpkin. And then I did need, as you can see, there's one segment. As you can see on top there's the little stem. I also did that part by drawing a hexagon and then extruding the hexagon. Again, I'm going through this briefly because it's beyond the scope of this video. And then of course I had to cut out the carvings. That was after the pumpkin is done. I did some carving. And then after carving I put back a piece of pumpkin there. I called it the visor, like so. So basically when you export this, there are two parts. It's the pumpkin and the visor. It needs printing, but you will see that the pumpkin is too big for most 3D printers, and actually I made it twice the size I want. So what I did, when I imported it in my slicer, I scaled it down to 50%, and then I cut off the top and printed it in two pieces, and that's how I created my lid. Import. So I imported the pumpkin, and as you can see it's way too big, so I scale it down first, and I scaled it to 50%, which means the visor opening is 10 millimeters high, and it will fit a LED strip perfectly. Now you can print this in one, but it will use a lot of support on the inside, and it's going to be hard to remove it. So what I did, I took my slicing tool, cut, and then I just moved that around, and then I made a lid like this, approximately like so. Perform cut, and then you have two parts. There you have it. And then both files are sent to the printer to be printed. Okay, so we have it, the pumpkin. Of course we have our lid. And as you can see, I put a little light in it, because that's also what you can do. You can just put a candlelight in it, but then I prefer not a real candle, but a flashlight. That's what I did here. So basically what you see in here is the LED strip. I didn't even bother to cut it to size, because this is the LED strip. Actually, I didn't even bother cutting it to size, because this is the original LED strip I used was the Larsen scanner, and of course it's way too long. Half the LEDs would suffice, but I just left it in there because I don't mind, and I just left it in there because I don't mind and I like the decoration. So what I did, I just put it in there like so, and there you have it. And of course this whole unit will fit inside, so I could just do it like this, turn it on, close the lid, and you're good to go. There it is, Cylon pumpkin. Actually the LED is right, but the camera doesn't really catch that. It's actually a red light and not a yellow, but it doesn't really matter. It's the way it looks. Maybe we can change that. There we have it perfectly. So let me show you the unit. The firmware I use is similar to the one I did in a vocoder. I just added a few lines, but I will include the code so you can take a look at that. It's not that spectacular. It's for 99% it's the same as the Larsen vocoder, so you can focus on that. So let me switch it on. And there you have it. It says Adafruit because I left the logo in there from the library file because I like it. But of course you can put your own logo there if you prefer. That's our display. And here we have it. Whenever you change the value of the potentiometer, you will also see the values on the display change. I don't know if I can zoom in more. No, okay. So what you see here is the Cylon Vocoder. We have a mode switch and a memory switch. The memory switch has not yet been implemented. That's something I will implement in a future update. My plan is to have a few basic settings that you like, and then you can store that settings and easily recall it instead of finding every settings all over again each time you use it. But right now it's not implemented yet. We do have a mode button, and the mode button is used to change the signal of the built-in function generator that we use to feed our vocoder. Okay, so we have a square signal, we have a linear square, a sin, a pulse, a saw, a reverse saw, and then we're back to square. And preferably I like the saw. But it's up to you, different taste, you know, different people, different taste. We have our, and for this I am going to take a peek on the lid. I'll just put it on here. Because we have our Larsen, that's the sound for the Larsen scanner. We have the pitch, that's the frequency of the built-in function generator that's used to feed the vocoder. We have a wet signal and a dry signal. Dry is the signal coming from the input directly to the output, and it's weakened or amplified. And we have a wet signal, that's actually the output of the vocoder. So the signal that has been vocoded. And the master is the main value. And of course I do have a few buttons. There we have it. Of course I will include all the files, the step files for the housing if you want to reproduce them. I will include the Gerber files for the PCB, so you can order your own PCB. You can decide not to use it, of course, like I did in the vocoder video. You can use a Teensy audio board instead and tinker around a bit in the Arduino firmware to make that work. It will work, but it's up to you. Another option is to buy the PCB as you saw it in this video with most components already pre-assembled. I will put it in the part list for you to find. So that's it. Let's move on to a demo. Oh wait, no, one more thing. Oh yeah, right. The Larsen scanner. Where does it go? Where does it go? The Larsen scanner, and then you have to make sure you got the polarity right. Goes there.
Hi, this is Marv from Untitled. Welcome.
Psst. Hey. Psst. Happy Halloween!
By your command. This is the Imperial Leader, by your command.
So this is all I have for you today. I hope you enjoyed it. Remember to check out the Element 14 project page. As usual, I will put all the information you need. I will put it there so you can reproduce this pumpkin and the electronics yourself. And if you have any questions, feel free to leave a comment or ask the questions there, and I will do my best to answer each and every one of you. While you check out the annual Halloween hackathon, I will think of more projects to build to scare my neighbors. Until then, I see you next time.